హాయ్ ఫ్రెండ్స్, వెల్కమ్ టు జిఎంకే ట్యుటోరియల్స్. ఇప్పటివరకు ఎవరైనా ఇంకా మన ఛానల్ సబ్స్క్రైబ్ చేసుకోకుండా ఉంటే సబ్స్క్రైబ్ చేసుకోండి. ప్లీజ్ షేర్ యువర్ ఫ్రెండ్స్ ఆల్సో. సో మీకు వీడియోస్ యూస్ అయితే మీ ఫ్రెండ్స్కి కూడా షేర్ చేయండి. ఓకేనా? మీకు అవసరం లేకుండా ఉన్నా కానీ మీ ఫ్రెండ్స్కి అవసరం ఉండొచ్చు కొన్ని సబ్జెక్ట్స్ అనేవి. ఓకేనా? సో థ్యాంక్ యూ ఫర్ గైస్ అప్ టు నౌ సపోర్టింగ్ ఫర్ మీ. ఓకే, థ్యాంక్స్ అలాన్. సో లెట్స్ go to the topic. So now our topic is y parameters. In the previous video we discussed regarding the z parameters. Now we are going to focusing on y parameters. Okay, now generally I think all of you having, let us see, um, where r is equal to resistance, you have some basic idea, right? Resistance can be represented as where z is nothing but impedance. Okay, as well as y is nothing but admittance. Okay, these are the some of the terms we frequently use in the electronic as well as electrical electronics departments, right? So let us say, what is the relation between z and y? Z is equal to 1 by y, right? Or else y is equal to 1 by z. This is the relation, right? Now in our previous video we discussed regarding the z parameters. Output voltage, voltage can be represented as a v is equal to z into I. So our y parameters is nothing but short circuit parameters. Okay, short circuit means obviously some current is, so generally if you are taking this output side, if it is a open means it is nothing but some voltage will be present at the output terminals, right? Suppose if it is a short circuited means that only current is flowing, voltage value 0. Alright, so that's why it is a short circuited parameters. Y parameters is also called as a short circuit parameters. Y parameters is also called as a short circuit. Okay, we can call as a short circuit parameters. So Z parameters are generally called as a open circuit. It is called as a short circuit parameters. So this is a one more different short circuit parameters. Okay, so short circuit parameters means that what we can get here from this equation, I is important. So these equations, y parameters equation can be represented in the form of a I1, I2 versions. So from this equation, suppose if you want to find out if you want to write the equation in terms of I, means that I is equal to, what is the value? V by Z format, right? 1 by Z format. You know guys, from the previous, so from this equation, 1 by z is equal to y, right? Therefore you can represent I is equal to y into v, right? Now you can represent the matrices form I1, I2. This is a basic equation for y parameters, so it can be represented the matrices format I1 and I2 is equal to y1, y12, y21, y22, as well as this equation can be represented as a v1 or v2, right? So or else it is also can be represented as function of, okay, I is equal to function of v1 comma v2 format also. Okay, so z admittance parameters are the quite opposite to the z parameter. It's very important guys. If you know the z parameters, definitely you can write the y parameters very easily. But the basic thing is that you have to know very clearly what is meant by two-port network, how we are going to calculate the Z parameters. If you know that basic reason, definitely it is easy for Y parameters as well as H parameters as well as ABCD parameters. So let us please concentration here. Here I1 is can be represented in the form of a equation. Basically, as a mathematics background, obviously you can know that multiplication of these two y11 into v1 plus y12 into v2. So this law. So if you are multiplying like this, I1 is equal to y1 into v1 plus y12 into v2 into, as well as I2 is equal to y21 into v1 plus y22 into v2. I think this guys is very easy guys. Just you have to give the numbers for these two equations, because of we need to compare these two equations in the next analysis process. So for that purpose, I1 and I2 equations can be represented as equation number 1 as well as equation number 2. Right? Coming to this one, so now we have to find out the what is the value of y11 and y21. So you need to calculate the coefficients of this y11. So here this y is generally called as the admittant matrix. In case of the Z parameters, Z is called as the impedance matrices, right? It is called as a impedance matrix. I can write shortcut. It is called as a admittance matrix. Admittance matrix, right? Now you have to analyze these two equations. How you are going to calculate it? Suppose if you don't have any basic data, let us see here very clearly. నీకు ఏం కావాలి ఈక్వేషన్ లో y11 ఫైండ్ అవుట్ చేయాలి లేదా y12 కానీ y21 కానీ ఫైండ్ అవుట్ చేయాలంటే కంపల్సరీ v1 కానీ v2 కానీ ఈ టూ ఈక్వేషన్స్ లో ఎనీ వన్ ఆఫ్ దమ్ ఫస్ట్ ఒక v1 వాల్యూ 0 అయి చేసుకోవాలి లేదా v2 వాల్యూ 0 చేస్తేనే దెన్ దెర్ ఇస్ అ పాసిబిలిటీ ఫర్ క్యాలిక్యులేషన్ ఆఫ్ ది y1. సో లెట్ us see here I have to calculate y11 క్యాలిక్యులేట్ చేయాలనుకున్నా. సో y11 క్యాలిక్యులేట్ చేయాలంటే కంపల్సరీ y12 వాల్యూ 0 కావాలి. y12 కోఎఫిషియంట్ 0. y12 కోఎఫిషియంట్ ఎప్పుడు 0 అవుతుంది? v2 వాల్యూ 0 అయితే v2 వాల్యూ 0 మీన్స్ దట్ ఏంటంటే అవుట్పుట్ పోర్ట్ అనేది షార్ట్ చేయాలి. షార్ట్ సర్క్యూటెడ్ పోర్ట్ లో వోల్టేజ్ వాల్యూ, ఓకే, వోల్టేజ్ వాల్యూ 0. సో ఇట్ ఈస్ వెరీ ఇంపార్టెంట్. ఎట్ షార్ట్ సర్క్యూట్ టెర్మినల్ voltage is 0. So from this idea you can represent above equation as I1 is equal to y11 into v1. So first consideration is nothing but output port is short circuit. That means v2 value is equal to 0. It is important. So v2 value is equal to 0 means that so y12 0. So from this equation I1 is equal to y11 v1. So now we can represent y11 is equal to y11 is equal to, we can call as a I1 by V1, right? This is the equation, right? I1 by V1 when V2 is equal to 0. In this case, how we are getting this equation? When V2 value is equal to 0, then there is a possibility. Therefore, Y11 is equal to, from this only we are getting this only. As well, so this is called as the input driving point admittance. This is called as the input side because of y11 is the input side. We can call as the input point driving admittance. Input point driving admittance, right? As well as if v2 is equal to 0, from the second equation also there is a possibility you have to calculate the one more parameter. So what is that one? When v2 is equal to 0, we can calculate y21 is also possible. y21 is equal to I2 by v1. Therefore from this equation y21 is equal to I2 by v1. Okay, so this is also second parameter in case of the y parameters, when these two parameters is calculated only when v2 is equal to 0. Suppose consider the third case when input port is short circuit. Input port is short. So what happens? V1 value is equal to 0. When V1 value is equal to 0, what are the parameters you are going to calculate it? So when V1 is equal to 0, you have to calculate y12 as well as y22. So from this, y12 is equal to I1 by V2. y12 is equal to, from this y12 is equal to I1 by V2. Okay, when V1 is equal to 0 consideration, as well as y22 is equal to I2 by V2 when V1 is equal to 0. These are the two more parameters in case of the Y parameters. It is also called as admittance parameters. These admittance parameters can be calculated by short circuit the corresponding two port network terminals. Therefore, we can call it is a short circuit parameters. Very important. Okay. So this Y12 and Y21 is also called as a reverse and forward transfer admittances. I1 by V2 is called as a reverse transfer admittance. I2 by V1 is equal to I1 by V2. I1 by V2 is equal to a reverse reverse transfer admittance. It is called as a reverse transfer admittance. Okay, this is called as a I2 by V2. Therefore, we can call it as a output second port side. Therefore, we can call it as a output driving point admittance. It is called as a output driving point admittance. Output driving point admittance. Okay, so this is also called as a Y21. This is called as a forward transfer admittance. These are the names for the Y parameters of the Y11, Y21, right? Now, let us see the some of the conditions like reciprocity condition as well as symmetric conditions in case of the Y parameters. So for that purpose, just let us see the considerations. Nothing but reciprocity means generally we know that Y parameters is nothing but reciprocity of the Y parameters from the just a minute 3.12 equation from this 3.12 minus I2 minus I2 is equal to, it's like a reverse sign actually, right? Minus, is there any minus signs are there in the equation? So better to see the short circuit considerations, right? So from this equation, is there any possibility from short circuit of those two? Short circuit of when short circuited happens means that V2 is equal to 0. V2 is equal to 0 means that I1 by V1 format, right? I1 by V1 is equal to I2 by V1, right? I1 by V2 is equal to, right? Y21 is equal to I2 by V1 as well as. So if you are getting these two equations, let us see just I will give the direct representation for this one. Okay, because of all of having some basic idea about this one. So you can get these two equations due to the short circuit of the V2 is equal to 0. Okay, when V2 is equal to 0, I can directly represent when V2 is equal to 0. Okay, 0. Negative sign indicates the direction of the flow of I2, outward direction. Okay, now, so sign is the outside direction. Therefore, Y21 is equal to, okay, when Y21 is equal to minus I2 by 2 by V1, right? So let us see, this is also possibility. Y21 is equal to I2 by V1. I2 by V1. Actually, minus means that it's a outward direction. Negative sign means that out out outward direction of outward direction of the corresponding diagram. Corresponding current actually I2 is in the outward direction. That's why we can represent. As well as if the port 1 V1 is equal to 0, what happens when V1 is equal to 0? It is a V2 is equal to 0, because when V1 is equal to 0, what happens is that if you are calculating V1 is equal to 0, you can get y12 is equal to minus I1 by V2 minus I1 by V2 minus I1 by V2. So from these two diagrams, so let us see, is there any similarity? Y12 is equal to I2 by V1 and I1 by V2. Okay, if V1 and V2 is same, okay, this is the analysis actually. If V1 and V2 is equal to same, when V1 and V2 is equal to same, what happens is that I2 by is same. The left hand side of the equation and so in these two cases, left hand side of this equation, this one is equal to these two. Okay, so from this the reciprocity condition of the y parameters is equal to y21 is equal to y12. This is the reciprocity condition for y parameter reciprocity condition. So symmetric condition means that y parameters from a two-port networks will be symmetric if input and output ports can be interchanged without changing the voltage or current. Okay, na? If you are changing the input and output ports without changing the voltage and currents, we will get this one. So that is nothing but condition for this one is equal to y11 is equal to y22. This is a condition for symmetry condition of y parameters, right? So let us see is some basic solution for this one, like whatever we discussed in the Z parameters. Like let us see one circuit diagram for this one. For calculate the y parameters. Okay, problem is that find y parameters for given circuit. Okay, so the circuit given is here. Okay, this is a given circuit. Actually, in case of the y parameters, what are the majorities? Okay, currents are the driving ports, right? So plus minus, this port can be treated as a V1, it can be treated as a V2, right? This is a V2, as well as the current is equal to the resistance of these corresponding terminals 1K. This is nothing but 2K. This is nothing but a 5 kilo ohm resistance. Okay, 5 kilo ohm resistances. Right. Now we have to calculate the y parameters for this circuit. Okay, for this circuit. So before calculating these kind of the circuits, let us go for one ideal case, then we will come to this one. Okay, then it is easy for us. So for that purpose, let us see the one ideal case circuit diagram for this one. Find y parameters. Find y parameters. In this consideration, the given circuit diagram is like this. In the form of some boxes will be there, like we can represent as impedances. So it is in the form of a pie like structure. We can call as a pie diagram also. Okay, na? We can also call as a pie diagram format also. If it is in the form of a T section network, if it is a pi section network, right? So let us consider the current directions for the circuit diagram. Okay, these are the voltage ratings of V1 at port 1, V2 at port 2, as well as current directions for this one. It can be treated as a I1, it can be treated as a I4, I3, I5, I2, right? Now let us see here. Just you don't have any voltage sources here, not connected to the corresponding. With the help of a nodal analysis only, you can analyze the problem, right? So this can be treated as a node 1. This can be treated as a node 2. Node voltage is a V1. This node voltage can be treated as a V2, like this, right? Now if you are applying the KCL at node, apply KCL at node 1. So ఇక్కడ KCL అప్లై చేస్తే ఏమవుతుంది? What are the current equations? I1 is entering, I3 plus I4 both are linked. Therefore from this equation I1 is equal to I3 plus I4. Generally I3 is equal to this direction. So it can be treated as a YA. This can be treated as a YC. Okay. This can be treated as a YB, impedances of this one, admittance of this one. Now I3 plus I4. Now from this equation I3 is equal to, generally we can represent I3 like resistance R is equal to, if you want derive the voltage across the current flowing this one is equal to node voltage of this one, reference node voltage, it's a node voltage. Therefore I is equal to reference V by V reference, that is equal to V by 0 or anything by like this. So this is a scenario between the difference of these two voltages, difference of these two voltages by corresponding resistance value. I is equal to V by V reference by R. So from this equation 0 is a reference node, therefore V1 is a node voltage, therefore V1, actually R is nothing but like you are taking a resistance. If it is impedance 1 by Z, if it is admittance, it is in the form of I is equal to, we can represent V by V reference into Y. V reference is nothing but this node. This node reference node is equal to 0. Therefore, V reference value is equal to 0. Therefore, V1 into Y1 plus what is the I4? I4 is equal to difference of these two nodes, right? V1 minus V2 into Y4 from this equation, right? Now Y1 can be treated as, actually we will call it as the YA actually. Okay, for this one let us consider as for this one. It is easy for representing next time, right? So no need to represent YA YB format, in case just we are taking in this one as in the V format for that one only. Okay, let us see for this one. Therefore I1 is equal to V1 into YA plus V1 into YB minus V2 into IB. So from this diagram, I1 is equal to, what are the common terms? If you are taking Y1 as a common, YA plus YB, YA plus YB into V1 minus what is this one? Actually YB, right? YB, not a IB, it is a YB. Therefore YB into V2. It is not equation number 3 I will consider. So from the one more equation, if you are applying the KCL at applying the KCL at I2, what we are getting here? I2 and I3 are entering into this I2 current and this I4 current are entering into the node, and I5 is leaving from the node. From the basic KCL equation, how we are going to apply the KCL apply KCL at node 2. What we are getting? I2 plus I4 is equal to I5. I2 is equal to difference of those two, right? I2 is equal to standard equation, that is nothing but V2, right? I2 is equal to, what is the value? Directly we can represent I2 is equal to, just I have to find out the correct, I mean, this is a Y parameters. Y parameters can be represented in the form of I1, I2, right? Therefore, just I am interested to calculate I2. Therefore, I2 is equal to I5 minus I4. Therefore, I2 is equal to, I5 is nothing but V2 by, V2 by Z actually. Just we are taking everything in the form of a Y parameters, right? Therefore, we can directly represent as the admittance of those value. That is nothing but YC, okay, YC minus I4 is equal to difference of those two. I4 is equal to V1 minus V2, V1 minus V2 into YB, right? YB. Now, if you are taking the I2 and if you are taking V1 as a common value, then we can get one negative value will be there. That is nothing but YB into V1. So plus, so minus into minus plus, then we will get to plus YB plus YC into V2. This is equation number 4. Now, if you are comparing these two equations, 3 and 4 equations with equation number 1 and 2, here we are marking as a equation number 1 and 2, we will get y11 and y12 and y21 and y22 values. Therefore, from this diagram, we can calculate it as, by comparing those two equations, what we are getting here, just I will write here in the beside of this one, it may be easy for writing here. So y11 is equal to this value, is equal to, what is the value? Ya plus yb, as well as y12 is equal to minus yb, so this value, as well as y21 is equal to minus yb, as well as y22 is equal to yb plus yc. So this is the y parameters for the bisectional. So it is also similar to this y parameters are similar to the for this network. If you want to calculate for this y parameters, we can directly write the, without solving this one, we can directly write this one now. Y11 is equal, what is the value? Y11 is equal to ya plus, if you are treating this a, b, it is a c, okay, just we will assuming like ya, yb, yc format. Now what we are getting here, I11 is equal to, just we are calculating the y parameters, admittance parameters of Z11, right? Y11, just y11 is equal to what is the value here? Ya plus yb, what is the value of ya? 5, yb value is equal to 1, then we will get 6 kilo ohms. Y12 is equal to minus yb, that is equal to yb value is equal to minus 1k kilo ohm resistance, as well as y21 is also minus yb, that value is also equal to minus 1 kilo ohms, as well as y22 is equal to yb plus yc, that is equal to yb is equal to 1, yc is equal to 2, therefore we can get 3 kilo ohm resistance. So this is the way we are going to calculate the y parameters, guys. Just if we know the logic, definitely you can easily calculate the y parameters from the given circuit. Okay, so I hope this video is very helpful for you guys. So thanks for watching GMK Tutors. Thanks a lot.